Now we take some questions from the exercise so that one can easily understand its application. That is actually the question number 6.3.5 from the Hogg, McCain and Craig's book. Let x1, x2 up to xn are the random sample from the normal distribution with mean mu naught and variance is equal to theta, where theta actually falls from 0 to infinity and mu naught is known. So show that the likelihood ratio test, that is based on theta is equal to theta naught versus theta alternative hypothesis, that is theta is not equal to theta naught, can be based on the statistic, that is actually statistic defined by the W, that is sum xi minus x bar whole square divided by theta naught, and this statistic is actually based on the null hypothesis, so that is why it is divided by theta naught. Determine the null hypothesis for the W and give the rejection rule for alpha level. So how we proceed for this one? So first of all, we have to find the two likelihood function. One is based on the null hypothesis, that is L hat gamma naught, that is actually 1 over 2 pi theta naught raised to power n by 2 into exponential, that is minus sum xi minus mu naught, because it is based on the null hypothesis, so xi minus mu naught, that is square divided by 2 theta naught. So this can also be written as, because this is equal to W, so we can simplify this like that, 2 pi theta naught raised to power n by 2 into exponential minus W over 2. Similarly, the likelihood based on the full parameter space, that is 1 over 2 pi theta raised to power n over 2, and that is actually exponential minus sum xi minus mu whole square over 2 theta. And we also know that the maximum likelihood of the theta actually, which is theta hat, and that is 1 over n sum xi minus mu whole square. So we can write it as the likelihood function based on the full parameter space as, that is L of this, and that is actually equal to 1 over 2 pi, और थीटा की जगह एक्चुअली हम उसका ml लिख देंगे, so that is actually 1 over n sum xi minus mu square and whole raised to power n by 2. And similarly in exponential, वहाँ भी हम उसका maximum likelihood estimator put करेंगे, so that is actually minus sum xi minus mu square over 2 into 1 over n sum xi minus mu square. So this will cancel out, तो हमारे पास जो नेट रह जाएगी ये चीज़, this factor remain as it is, and exponential, that is minus n over 2. Now we write down the likelihood ratio test, that is actually lambda x, and that is actually equal to L hat gamma naught divided by L hat gamma. So this implies that after putting their respective values and simplifying, we get lambda x, that is n raised to power minus n by 2 e raised to power n by 2 w raised to power n by 2 and e raised to power minus w over 2. ये जब इसकी वैल्यूज हम पुट करेंगे और इसको सिंप्लीफाई करेंगे तो ये हमारे पास रिजल्ट आ जाएगा. So we can easily see that, so these two are the constant and the test actually based on the statistic W. So this test actually based on W statistic. So the likelihood ratio test reject H naught if lambda x less than or equal to k, and on the same line k is determined by the size condition. So that is actually n raised to power minus n by 2 e raised to power n by 2 w n by 2 e raised to power minus w over 2 less than or equal to k. और फर्दर कांस्टेंट अगर हम इसको मर्ज कर दें k के अंदर तो वी विल फाइंड दैट w raised to power n by 2 e raised to power minus w by 2 less than or equal to, let's say we call it k1, where actually k1 is equal to k into n raised to power n over 2 into e raised to power minus n by 2. So next our task is to find the k on the basis of the size conditions. So our size condition is now, that is probability n sum x minus mu naught square over theta naught less than or equal to k1, and that is actually equal to alpha. So this is under the null hypothesis. Next we have to find the distribution of this quantity. So if we write down this as this one, because since we know that since xi's are from the normal distribution, and we know that the chi-square x square follows the chi-square with 1 degree of freedom. So in the given case, in the given situation, under root n theta naught sum xi minus mu naught, actually it follows the standard normal as usual. Then n over theta naught square sum xi minus mu naught square follows the chi-square with n degree of freedom. So on the basis of alternative hypothesis, reject H naught if, let's say, W is greater than or equal to C1 or W is less than C2, where C1 and C2 are the constants, as we know that W actually based on some x minus mu naught square over theta naught, and it follows the chi-square with n degree of freedom. So actually C1 and C2 are representing the upper and lower quantiles of chi-square with n degree of freedom. So this is basically the rejection rule for this one.